Continuing the lesson from distance bearing problem, right? And this, the example 3. I'm sure you did the number 2 and I hope you felt good, right? So let's look at the example 3, which says an airplane flew from town A, travels 200 kilometers at a bearing of 135 to town B. It then travels 250 kilometers from town B at a bearing of 45 degrees to town C. Find I, the distance of A from C, and then II, the bearing of A from C. So the first part you're looking for distance, and the second part is looking for what? The bearing. So let's quickly look through. Let's pay attention to the first statement. An airplane flying from town A to town B and the distance is 200 kilometers at a bearing of 135 kilometers to town B. So quickly, I'm gonna go ahead. Remember the step says draw a rough diagram, right, to show the whole thing. So at town A, this is my town A. And it moved 135 degrees. Remember, this is my 90. I have my 180, right? So I want 135. So 135 is gonna fall within the second quadrant. So we have 90. How much more do we need to get 135? You just need 45, and 45 is just half of the second quadrant. So 45. It tells me I just gotta move. And it's 200 kilometers, so half of it. And it moved to what? Town B. So I go here, and this is my town B. Right, so we have our town B here, and that one is 200 kilometers. The distance, remember, is 200 km. Now let's look at the second part. What does it say? It says it then travels 250 kilometers from town B at a bearing of 45 degrees, right? So I'm at town B and I just want 45 degrees. This is 90 degrees. So 45 will just be half of it, and it just traveled 250 kilometers. So that's basically half of it, right? That's gonna be half of this, just half of this. So here, that's gonna be my 45 degrees. So basically this is 45 degrees. And here I forgot to write that. That's also, remember it was also 45 degrees. We just needed that to done. So here, this is gonna be my town C. Right, this is my town C. This is our town C. Right, so we have town A, B, and C. Right, so we just have our rough triangle here. Right, we have our triangle there. Right, so based on the information that has been given us, and this is 250 kilometers, because it says the distance between B and C is 250 kilometers, right? So we have our rough diagram here. So what are we supposed to do? Let's look at the I. What does the I say? Find the distance of A and C. So to find the distance of A and C, we have to go back to the rough diagram we have. It's actually a triangle, right? But we just want to find out, is it a right-angled triangle? To find out if it's a right-angled triangle basically means is one part of it a 90 degrees? So we have to establish that far before we can now move on. Okay, so when we go back to town A, we can say this particular angle here, let me use this angle here which is this, we can say it alternates with this angle here, right? So if there is 45, then this is also going to be 45 degrees, right? And the whole of that, the whole of this is supposed to be 90 degrees. So if half of it is 45, then the other half, the remaining part, here is also 45 degrees. Then that part is also 45 degrees. So 45 plus 45, we have 90 degrees. So we've now been able to establish that this part is going to be 90 degrees, right? So meaning we have a right-angled triangle. Then we can justify that we can draw something like this from this particular diagram. We can draw a right-angled triangle. We can draw this way, right? And this is gonna be our B, because that's where we have the right-angled triangle, and this is our A, and then we have our C, and the distance between A and B is 200, and the distance between B and C is 250 kilometers, right? Then we can, since we have been able to establish this, then we can go ahead and look at our I. I says the distance of A from C. It's telling us the distance here, this particular distance. That's why it's telling you to look for how long it is, right? If we're able to do that, then we have to use the idea of the Pythagoras theorem. That's the hypotenuse, right? So with I, we can say then the magnitude, which is A, if I see the magnitude of A squared, AC squared is going to be equal to AB squared plus BC squared, right? If you remember this, hypotenuse square equal to opposite square plus adjacent square. That's just the idea we are using here, right? So we can go ahead and say our AC squared is going to be AB, which is 200 squared plus 250 squared, right? So now I'm going to say my AC squared is now going to be equal to what? Let's get our calculator here. So I have 200 squared plus 250 squared. Then I have 102,500. So when I come back here, I have my 102,500. Right, so if I want AC, I just have to take the square root on both sides, because I want to take the square root on this side, take the square root on this side, right? So here, automatically, 2 is going to cross out the square root sign. So I now have my AC. The magnitude of the AC is now going to be equal to what? The square root of 102,500. That's 320, approximately 320 kilometers. So when I come back here, I know it's going to be 320 kilometers. So it tells me that with the first part, the distance of A from C is 320 kilometers. Right, guys? I hope this is clear. So we've now been able to say this pace is going to be 320 kilometers. Right. Okay. Now let's go and talk about the II. What is the II talking about? The II is saying that look for the bearing of A from C. What does it mean? It tells me that I have to go back to C, say from C. So this is my north. I'm at the point C. This is 90 degrees. Let me extend this. All right, this is 90. This is 180 degrees. Right, so the question is, if I'm at the northern part of C and I want to turn to look at A, because it said the bearing of A from C. So I'm from C, the northern part, I'm turning. How much do I have to turn all the way here to get to the point A? That's just the bearing, right? And remember, if I turn here, this is 90, 180. So all what we need to look for is this particular angle and this angle, and then we are done, right? But how do we do that? To be able to do that, it's easy. Now let's look at the easy part then before we now go ahead. First of all, we can get here easily by looking at the bottom here. Look here. When you look at this angle, I'm going to focus on this angle. Look at the angle where I'm shading, right? You realize that that angle alternates with this angle that we're looking for. They are alternate angle. Therefore, if this 45, this angle is also what? 45 degrees. So now we have this. We are now left with this particular angle. Just that particular angle. And we can call that, let's call that particular angle theta. Let's call that angle theta because we want to look for theta. So automatically, this is the angle we are looking for, which is theta. So when I come here, I'm looking for this theta. Right? So here, let me clean what we have here. So we now have this, we want to look for theta. So I come here, I'm looking for II. This is II. And we have to look for theta. And we use the idea of the SOHCAHTOA, right? So if I want to focus on the original one, I can use tan because I have my opposite and adjacent. And this is my theta. So I'm going to say my tan theta is going to be equal to the opposite, which is 200, all over the adjacent, which is 250, right? All right, so let's move on here. So I'm going to clear, I have 200 divided by the 250, and which is 0.8. So now I know my tan theta is equal to 0.8. Right, so if I want to get theta by itself, then I have to take tan inverse. So theta is going to be equal to the tan inverse of 0.8. Right, so on the calculator, you just got to go to your calculator. If you want to get tan inverse, you hit shift, press shift before you press the tan. So you see the tan inverse has come. Then you just press 0.8, close the parenthesis and hit enter. And it's 38.6. So approximately that is 39. So we're going to say that when I come back to mine, I have my theta is going to be equal to 39 degrees. So when I go back, I know this angle is now 39 degrees, right? And we want the total place. So now all what we need to do is to add 180 plus the 45 plus 39 because we are looking for the whole of that turning. Let me go over that particular turning again. We are looking for the whole of this turning, coming here, this whole turning coming towards here. So that's going to be 180, 45, and then 39. So we're going to see the bearing, right? So let's choose this. The bearing of A from C will be equal to 180 plus 45 degrees plus the 39 degrees that we just found, right? So we have 180 plus 45 plus the 39 that we just found, which is going to be 264 degrees. So we now have 264 degrees, right? Guys, I hope it's clear. You just have to take your time, watch the video. You can replay it countless times to really get it. And it will help you solve this particular question, which is question 4, right? So you got to solve question 4 and send it to master. Thank you so much for taking your time to listen to the video. All right, see you in the next lesson.